Now, the second topic of this module is total productive maintenance. We did talk about um, many preventive maintenance, and total productive maintenance is essential for control phase because it builds up a culture for all the employees and team members to work together and work toward process improvement. Total productive maintenance, TPM, can be defined as an activity that promotes coordinated group activities for greater equipment effectiveness and requires operators to share responsibility for routine machine inspection, cleaning, maintenance, and minor repairs. Most important features of TPM are efforts to maximize equipment effectiveness, a system of productive maintenance for a machine's lifespan, implementation by engineering, operations, and maintenance, involvement of every employees, and autonomous maintenance by operators, company-led small group activities. Objective is zero breakdowns and zero defects due to equipment. Reports of first achieving 2% of original breakdowns and 90% of reduction in process defects says that 90% uh, of the productivity in equipment will be a great goal. Visual factors such as production boards, schedule boards, or malfunctioning signals should be used to easily see what is happening in the maintenance system. Six big losses from maintenance. The sources of six big losses are equipment failures, setup and adjustment, and idling and minor stoppages, and reduced speed, and process defects, and reduced yield. These are, the sources of six big losses. And according to the textbook, the goal should be breakdown losses should be zero, and setup and adjustment losses should be less than 10 minutes. That's an impressive one. And speed losses will be zero, and idling and minor stoppage losses should be zero, and quality defect losses should be zero, and yield losses should be minimized. If these are implemented, which is really tough to achieve. It's a world-class process. TPM metrics. There are metrics that can be used to gauge the productivity of the equipment. The first one is overall equipment effectiveness that can be calculated by availability times performance efficiency times rate of quality products. And availability is derived from this formula, operation time over loading time. And that's the same with loading time minus downtime over loading time. So that's availability. You can calculate that. And you also find the performance efficiency and rate of quality products and put them together. And you should be able to get overall equipment effectiveness. Here's an example. If there are 480 minutes per shift, 15 minutes of setup time, 10 minutes of planned downtime, 30 minutes of unscheduled equipment failures, what is the loading time and availability? Loading time, as we learned just now, available time per shift minus planned downtime. So therefore, 480 minus planned downtime 10 minutes gives you 470 minutes. Therefore, availability will be loading time minus downtime over loading time. So 470 minus 30 plus 15 minutes over 470, then it gives you 90.4%, which is really, really good effectiveness. Let's continue to learn TPM metrics. Operating speed rate equals theoretical cycle time over actual cycle time. Here's an example. If the theoretical cycle time is 1 minute per unit and the actual cycle time is 1.5 minutes per unit, what is the operating speed rate? In this case, operating speed rate equals theoretical cycle time over actual cycle time. Theoretical cycle time is given as 1 minute. Actual cycle time was 1.5 minutes. Therefore, operating speed rate is 66.7%. Now, net operating rate equals actual processing time over operating time. And this can be further derived by this process amount times actual cycle time over operating time. So let's take a look at this example. If the process amount is 185 units, the actual cycle time is 1.5 minutes per unit, and the operation time is 425 minutes. What is the net operating rate? In this case, if you put this formula, the number into the formula, then net operating rate is 185 times 1.5 divided by 425 gives you 65.3%. Lastly, performance efficiency equals operating speed rate times net operating rate. So if you found all this number from the previous formula, then you can easily find performance efficiency, which is 43.6%. So when you look at this efficiency, we see that this productive maintenance, preventive maintenance is not as good as we thought. Now let's look at OEE, overall equipment effectiveness. This is defined as availability times performance efficiency times rate of quality products. And TPM price winning companies have OEEs above 95%. Very impressive. Ideal conditions are availability should be greater than 90%, performance efficiency should be above 95%, and rate of quality greater than 99%. Then you can achieve 95% of efficiency rate or OEE, overall equipment effectiveness. Here's an example. If the rate of equality product is 95%, the OEE is from the previous example, overall equipment is 0.904 times 0.436 times 0.95 gives you 37.4%, which is really low from the benchmarking metric. Let's take a look at this question. Which of the following would be considered one of the 6 big negative contributors to equipment effectiveness? A. Setup and adjustment. B. Increased speed. C. Enhanced yield. D. Work set arrangement. We learned from the previous slides that it is setup and adjustment. So A is the answer. Next question. TPM in relationship to the lean enterprise system means A, total productive maintenance to maximize equipment effectiveness. This is the right answer, right? B, total preventive maintenance to reduce total cost. We are not, concerned about total cost at this moment. C, total process management to manage process cost. D, total preventive maintenance to minimize downtime. D is somewhat close, but the best answer is A. Next question. What is the equipment availability if there are 7.5 hours available per shift, 30 minutes of setup time, 15 minutes of planned downtime, and 15 minutes of unscheduled equipment failure? So loading time is defined as available time minus planned downtime. And here available time is 7.5 hours times 60 minutes minus 15 minutes of unscheduled equipment failure. So loading time is 435 minutes. Now, in terms of availability, we know that it is loading time minus downtime over loading time, right? That's what we learned from the previous example. So here 435 minus 30 plus 15 and divided by 435, that gives you 90%. So the answer is C, 90%. Last question from TPM. Assume an operating speed rate of 80%. If 40 units are produced at 2 minutes per unit in 2 hours, what is the performance efficiency of the work unit? So we learned three equations about this, and we have to apply that to find this answer. So performance efficiency, we know that it is defined as operating speed rate times net operating rate, where operating speed rate is kindly provided in this question as 80%. And we just need to find the net operating rate. And net operating rate can be found from another formula, which is net operating rate equals actual process time divided by the operating time. And this is again broken down into process amount times actual cycle time divided by operating time. From the question, the operating time was 2 hours, namely 120 minutes. Process amount was 40 units, and actual cycle time was 2 minutes per unit. So plug these numbers into the formula net operating rate, then it becomes 80 over 120, and that becomes 100, 0.667. So we find that net operating rate is 0.667. Now going back to the first equation, well, we can calculate performance efficiency as zero point 0.8 times 0.667, which yields to 0.534. So the answer is C. So it's a little bit convoluted, but if you just follow the formula, it's not that difficult.